Guys, welcome to lesson 8.5 on adding, subtracting rational expressions. Adding and subtracting rational expressions is going to take on a significantly different feel than what we did in section 8.4 when we were dealing with multiplying and dividing. Primarily because when we multiply fractions, again, a over b times c over d, we just multiply tops and bottoms and then we can simplify the results. Adding fractions, however, requires us to have a common denominator. Okay? And so if I need a common denominator to add, and these are going to be some sort of rational expressions involving x, this lesson has a tendency to get a little bit hairy. So let's take a little bit and talk about some vocab. First of all, a complex fraction is a fraction that contains a fraction in its numerator and a denominator. So again, this is a fraction within a fraction. All right? So that's really the gist of the vocab for this lesson. So let's take a look then at adding and subtracting rational expressions. To add or subtract rational expressions with like denominators, simply add or subtract their numerators. Now again, if the denominators are the same, you can just add or subtract the numerators. Then place the result over the common denominator. Let a, b, and c be polynomials where c is not equal to 0. So again, if these are the same, then it simply becomes a plus b over c. And if these are the same, this is a minus b over c. So if they have a common denominator, you just add the tops and simplify. So let's take a look at an example here. This is 9 over 6x plus 2 over 6x. Well, that just simply becomes 9 plus 2 over 6x, which is 11 over 6x. Now, you're looking at that and saying, well, that's not so difficult, right? But what happens if they have unlike denominators? Now things get a little bit crazy. All right, so to add or subtract two rational expressions with unlike denominators, first find the least common denominator. Okay, and the least common denominator, another way to say that is the least common multiple. Okay, so if I talk about the least common denominator and the least common multiple, I'm talking about the exact same thing. The smallest number that both of them go into is their least common multiple, and therefore that is the least common denominator. Rewrite each of the rational expressions using the least common denominator, then add or subtract using the procedure for like denominators. So again, in this case, the least common multiple, or the least common denominator of c and d, is simply c times d. So to get this, a over c, to have a denominator of c over cd, we would just multiply both top and bottom by d, and I get ad over cd. The least common multiple of c and d is cd. So again, to get this to look like this, I got to multiply top and bottom by d. To get this to look like this, I got to multiply top and bottom by d, and so it becomes bd, I want to change that, over cd. All right? And so then, since they're both over the same denominator now it's simply ab, I'll try that again, that's ad plus bd. All right, same thing goes here, and again, they've got that same typo here. To get the least common multiple of c and d, that's cd. All right, and so to get this to look like this, I got to multiply top and bottom by d. This becomes ad over cd, which is your first term here. To get d to look like cd, I got to multiply top and bottom by c, so this becomes dc or cd, and b times c, which is b times c. Oh, I guess that was okay. And so what we're going to do then is we are going to take a look then at, this would then be AD minus BC over CD. All right? So that is the gist of that piece. Now let's take a look at an example here where we're adding something with unlike denominators. All right? So we need to add these two things together, and it's very evident that these two things are not the same. So I need to figure out what is the least common multiple of 4x squared and 2x squared plus 4x. So if I write 2x squared plus 4x as its factored form, that is 2x times x plus 2, And this, I'm going to write this as 2 squared times x squared. All right? So I need to find the least common multiple or least common denominator, either one of those two. So the smallest number that both 4 and 2 both go into is 4. All right? The smallest power of x that x squared and x both go into. Now, we're not talking about factors now. Now we're talking about the smallest quantity of x that x squared and x both go into. Well, that's x squared. And we have to have at least this x plus 2 for each. Even though this one doesn't have any x plus 2's, we have to figure out the smallest, the least common multiple of all of those terms. Now, we don't simply do 2 times 4 and get 8 here, because again, there is a common multiple of 4 and 2, it's 4. And there is a common multiple of x and x squared, and it's x squared. So remember the conversation before, we said, look, we need to get both of these denominators to now look like 4x squared times x plus 2. So let's fill in some blanks here. To find the least common denominator, factor each denominator and write the highest power to which each factor occurs. Note that 4x squared becomes 2 squared x squared, and 2x squared plus 4x becomes 2x times x plus 2. So the least common denominator is 4x squared times x plus 2. All right? So what we have to do is we have to get both of these bottoms to look the same. So again, we're going to write this in factored form. So this is 2x times x plus 2. And so we then have to ask ourselves, in this first fraction, what do I have to multiply 4x squared by to make it look like 4x squared times x plus 2? Well, if you said x plus 2, you're on the right track. All right? In the second fraction, again, this is 2x times x plus 2. And so to get 2x times x plus 2 to look like 4x squared times x plus 2, I need to multiply by 2x, because 2 times 2 gives me 4, and x times x gives me x squared. So I need to multiply both top and bottom by 2x. Now, we're not going to distribute this because we already factored it. Instead, we're going to combine 2x times 2x, and we're going to get 4x squared times x plus 2. On the top, we do have to distribute this. So this becomes 2x times x and 2x times 1, which is, this is now 2x squared plus 2x. All right? Now let's go back over here and take a look at this guy. Again, we're not going to distribute this 4x squared to both things because we already have it in factored form. But we are going to distribute the 5. This becomes 5x plus 10 over 4x squared times x plus 2. Now, do my denominators match? Take a look at our denominators in both of these fractions. See how these are exactly the same? All right? And so because those two exactly match, okay, now all we have to do is combine the tops. Since it's a plus here, we're just adding across the top, so we're just combining like terms. The only power of x squared is 2x squared. Cross it off. Now let's go with x to the first. That's plus 7x to the first plus 10. And the whole thing is over 4x squared times x plus 2. All right? Now, we're not going to be able to simplify this on the top at all. And so I think we're done here. All right? And so that is our first example of finding a common denominator. All right? Let's try one with subtract. All right? Once again, we have to find the least common multiple of these two denominators. So I want to write them both in factored form. The factored form of 3x plus 9 becomes 3 times x minus 3. And the factored form of x squared minus 9, well, guys, remember, that's the sum and difference pattern. That's x plus 3 times x minus 3. All right? So those are my two denominators, 3x minus 9 and x squared minus 9. All right? And so I need to find the least common multiple. Well, they both have an x minus 3. All right? This one doesn't have an x plus 3, so I need to give an x plus 3. And this one doesn't have a 3, so I have to have a 3 there as well. All right? The smallest number, the smallest quantity rather, that 3 times x minus 3 and x plus 3 and x minus 3 go into are 3 times x plus 3 and x minus 3. All right? So we figured out what's common, and then we kind of filled in the rest. All right, so we're going to rewrite this as 3 times x minus 3. And we're going to write this as x plus 3 times x minus 3. And again, my thought is I want to make this denominator right here, I want to make that look exactly like this. So I've already got a 3, and I've already got an x minus 3, so I need to multiply both the top and bottom by the x plus 3 to get them to match up. All right? The second one is x plus 3 times x minus 3. So I already have these two factors, so I need to have a 3, and what I do to the top, I also have to do to the bottom. All right? Here we're going to distribute, so this is going to become 3x plus 12. All right, and this is all over 3 times x plus 3 times x minus 3. All right, back here in the first set, 7 times x and 7 times 3 becomes 7x plus 21. And again, this is all over 3 times x plus 3 times x minus 3. And again, the order of those two don't matter. Now, be especially careful in recognizing that you are subtracting here. The common denominator is 3 times x plus 3 times x minus 3. Now, on the top, you're doing this, take away this. So we're subtracting the whole thing. Make sure then you add the opposite and the opposite. So this becomes 7x, take away 3x, which is 4x. And then 21, take away 12, which becomes 9. All right? And unfortunately for us, or rather fortunately I suppose, this does not factor, so we can't worry about factoring anything out and reducing. And so we're all done here. All right? Okay, so at the top of the next page there are 4 checkpoint problems, and these are going to take you some time. So go ahead and try these 4 checkpoint problems and resume your video, and we'll run through these together. Okay. In example 1, these already have a common denominator, so you are simply doing 8x minus 7. This is 8x minus 7 over the common denominator of 3 plus x. In the second example, they're both over 3x already, so this becomes 13 plus 2, which is 15. All right? Now, they weren't quite so nice to us in the second example. All right? X squared plus 6x plus 9. Well, x squared plus 6x plus 9, this is the same thing as x plus 3 times x plus 3. All right? And in the second example, the second denominator is x plus 3 times x minus 3. All right? So it looks like the least common multiple is going to have a pair of x plus 3's and an x minus 3. So our least common multiple, or least common denominator, is x plus 3 squared times x minus 3. So we're going to rewrite this guy as x plus 1 over x plus 3 times x plus 3. And I'm going to save some space here. 6 over x plus 3 times x minus 3. And again, we're going to multiply the top and bottom of the first fraction by x minus 3, because my least common multiple is x plus 3 times x plus 3 times x minus 3. All right? So I need a pair of pluses and one minus, and so I need to have x minus 3 over x minus 3. We'll deal with simplifying in a second. In the second one, we've already got one of each, so I need 2 x plus 3's, or a pair of them rather. All right, so I'm going to multiply top and bottom by x plus 3. Now we are adding here, so this one isn't nearly as difficult, but we are going to distribute. This becomes 6x plus 18 on the top. Over here, we have x plus 1 times x minus 3, and so we have to FOIL that. That becomes x squared minus 2x minus 3. And again, you can FOIL this, or you can use Punnett squares, or however you use it is fine. And the whole thing is over x plus 3. And now if you want to write it x plus 3 squared times x minus 3, that's fine. All right? Now, on the top of this thing, we have to combine like terms. We only have one x squared term, so it's x squared. Now, how about x's? Well, we have positive 6x and negative 2x, which is plus 4x. And then we have 18 take away 3, which is plus 15. The whole thing is over x plus 3 squared times x minus 3. All right? So that one's pretty tricky. Let's go ahead and try the next one, example number 4 here. We need to find the least common multiple of 4x squared and 8x squared minus 12x. So rewrite this as a factored form. What number goes into both 8 and 12? Well, that's 4. And we can bring at least an x out of both. So you're going to bring out a 4x. That leaves me 2x and then minus 3. All right? Again, check that. 4 times 2 is 8. X times x is x squared. 4x times negative 3 is negative 12. In the top quantity, this is 4x times x. All right? So it looks like the only thing common is the 4 and the x. But we need another x, so make it squared, because this one's got a pair of them. All right? And then we also have to have this 2x minus 3. All right? So both the denominators have to have 4x squared times 2x minus 3. All right? So that says in the first one, we're going to have to do 4x squared. We're going to have to multiply the top and bottom by 2x minus 3 and 2x minus 3. We're subtracting 2 plus x, and I'm going to erase this over here now so I've got some room. Kind of clean some of this up a little bit just so I've got a little bit more room. We know what our common denominator is. We have to put that over the original, and we're going to write that as 4x times 2x minus 3. And so I need, basically, to get this to be 4x squared times 2x plus minus 3, we need to be over x and x. All right? So when I multiply this whole top quantity by 8, this becomes 8 is 16x minus 24. So this is going to become 16x minus, run out of room here, minus 24 all over 4x squared times 2x minus 3. And I'm going to subtract from that 4x squared over 2x minus 3. I'm going to subtract from that when I distribute the x here. This becomes 2x plus x squared. Now again, we're subtracting all of these, so we're going to make that plus a negative and a negative. All right? Now, the bottom isn't going to change. Okay, the bottom isn't going to change, and I apologize for running out of space. You guys can move down and write a little bit more. I'm going to try to write this up here now. And so we're going to kind of slide up over here. The only x squared is this right here, so negative x squared. And then we have 16x minus 2x, which becomes 14x. And then I have the minus 24. And again, the whole thing is over 4x squared times 2x minus 3. All right, so that's it. That is the adding and subtracting by first finding a common denominator. Now let's talk a little bit about simplifying complex fractions. Again, this is when you have a fraction within a fraction. All right, so a complex fraction is a fraction that contains a fraction in both its numerator and its denominator. Okay, so it's got a fraction basically in the top and the bottom. There are two methods to simplify this. One of them says, if necessary, simplify the numerator and denominator by writing each as a single fraction. Then divide the numerator by the denominator. All right? The second way to do this is to multiply the numerator and denominator by the least common denominator, and I'll just put LCD or LCM, of every fraction in the numerator and denominator, and then simplify. Okay? So let me ask again, what does it mean to divide fractions? Well, dividing fractions means to multiply by the reciprocal. We can simplify this denominator right here, ignoring the rest of it, because they already have a common denominator of 15. This becomes simply x plus 1 plus 4, which is x plus 5, all over 15. Now, we know that dividing fractions, fraction divided by a fraction, means multiplying by the reciprocal. All right. Now, just like we talked about in last section, we would then multiply the. We would go ahead and multiply the tops and the bottoms here. But before we do that, I think it's probably easier to simplify first. So I'm going to say, look, 5 goes into 15 3 times, 8 times 3 is 24. And on the bottom now, I have x times x plus 5. And if I want to leave that as x times x plus 5, I can. Okay, but since we're simplifying completely, let's go 24 over x squared plus 5x. Okay? That's the best we can do with that one. Now, let's try a little bit different method here. Let's try to do this same idea where we multiply both the top and the bottom of this thing by the least common multiple. So in this case, see, we can't simplify these. These can't go together as one fraction because they don't have a common denominator. So as long as we're finding the least common multiple of 3x and x plus 1, well, it's obvious then that since they both have no common factors, the least common multiple is 3x times x plus 1. So I'm going to multiply the top and the bottom by 3x times x plus 1. And I'm not going to actually multiply those out. I'm just going to write it like that. Okay? Now, each of these terms, 1 over 3x, is going to be multiplied by 3x times x plus 1. So this becomes 1 over 3x times 3x times x plus 1. Well, the 3x and the 3x are going to cancel, and I'm going to be left with simply x plus 1. All right? Continuing then, I'm going to multiply this by 3x plus 1. Well, the x plus 1 is going to cancel with the x plus 1 on the bottom and on the top, and so I'm going to be left with 2 times 3x, which is simply 6x. On the top of this thing, the same idea. The x plus 1 is going to cancel with the x plus 1, and I'm going to be left with 2x times 3x, which is 6x squared. So on the bottom, this is x plus 6x, 6x squared over 7x plus 1. And that is our product. All right? So you've got the rest of this thing to finish up. You've got 2 checkpoint problems, and I will give you solutions for these, and we'll go right ahead and get into the end of this lesson. So try these 2, and I'll be right back with solutions for you. All right, so in the top of this thing, we want to write this as one fraction. This is 6x over 4 minus x over 4. Well, that simply becomes 5x over 4 because they already have a common denominator. In the bottom, this is then 8 plus 3x over 2. Dividing fractions means multiplying by the reciprocals. So we're going to multiply by the reciprocal of 8 plus 3x over 2, which is 2 over 8 plus 3x. Now, before we multiply, we could do 10 and then distribute and make a mess of this thing. Now we're going to have to reduce. Let's reduce first. 2 goes into 2 once, 2 goes into 4 twice. This becomes 5x over, and then 2 times 8 is 16 plus 6x. Okay? All right. Finally, for the last one, like we said before, since these can't go together, you have to find the least common multiple of 2x and x squared. Okay, well, I need at least an x. This one's got one x, this has got a pair, so I need an x squared. This one does not have any constants, and so I need 2x squared is the least common multiple. All right? So I want to multiply the top and bottom of this thing by 2x squared over 2x squared. All right? So when I do that, then, this becomes, and I'll write this one out, 5 over 2x times 2x squared plus 7 over x squared times 2x squared, all over 3 over x squared times 2x squared, minus 1 over 2x times 2x squared. All right, so let's get started canceling some stuff out here. All right, 2x cancels with 2x squared, and so again, the 2 cancels with the 2, the x cancels with one of the x's, so I'm left with simply x to the first power. Here, x squared cancels with x squared, I'm left with simply 2. Here, x squared cancels with x squared, I'm left with simply 2. And here, 2x cancels with the 2 and one of the x's, leaving me just an x. So on the top of this thing, I have 5x plus 14. And on the bottom of this thing, I have 2 times 3, which is 6, plus, and then 1 times x is just x. So I get 5x plus 14 over 6 plus x. All right? So quite a tedious lesson in terms of finding that common denominator, but that concludes lesson 8.5.